Astronomers have officially registered the interstellar object designated 3/ATLAS, only the third such visitor ever recorded entering our solar system. It arrived on a hyperbolic trajectory, moving at a velocity that defied gravitational capture, a silent wanderer from the depths of interstellar space. Initial observations classified it as a peculiar, fast-moving comet. However, this preliminary assessment was shattered by data from humanity's newest and most powerful eye on the cosmos, the James Webb Space Telescope, JWST. The anomaly was subtle at first, buried in the near-infrared data streams. JWST's sensitive instruments detected a steady, rhythmic pulsation of energy emanating not from the object's sunlit surface, but from deep within its core, a type of emission utterly inconsistent with a simple, inert celestial body, like a comet or asteroid. This was not the chaotic flicker of outgassing ice, but a precise beacon-like signal. Subsequent measurements confirmed the staggering reality. 3I/ATLAS was shining with a thermal brightness approximately 3 times greater than any standard model predicted for an object of its estimated size and distance from the Sun. Crucially, this luminosity showed no signs of a diffuse coma or a trailing tail of dust and gas, the classic hallmarks of cometary activity. Instead, the object appeared as a compact, brilliant point source. Even more confounding was its rotational behavior. Light curve analysis revealed a rotation period of roughly 6 hours, but the curve itself was remarkably flat, devoid of the expected peaks and valleys caused by surface irregularities or jet activity. The rotation was perfectly uniform, smooth, and stable, akin to a precision-engineered gyroscope. The discovery of this thermal pulse was soon independently corroborated by several observational teams. The pulse repeated with metronomic regularity, cycling every hour. To the scientists monitoring the data feeds, it appeared less like a natural geological process and more like a deliberate, periodic release of energy. Delving deeper, analysts focused on JWST's initial infrared captures. The images were unequivocal. They showed not a fuzzy extended atmosphere, but an intensely concentrated point of light at the object's exact center, overpowering the faint glow of any surrounding particulate matter. All diagnostic checks ran clean. The signal was not an artifact of instrument noise, calibration error, or interference from solar activity. The inescapable conclusion was that the heat source was endogenous, powered from within the object itself, and indifferent to external solar heating. This revelation triggered a full-scale observational campaign. Optical teams working with the Atlas survey in Chile and analysts processing Hubble Space Telescope data conducted urgent follow-up studies. Their findings only deepened the mystery. The object's light curve, constructed over weeks, remained stubbornly constant, a flat line on a graph where a variable, breathing curve was expected. Hubble, with its unparalleled resolution, sought the telltale signature of sublimating ice, a faint tail or jet. It found none. Instead, 3I/ATLAS was enveloped in a faint, symmetric, and unusually dense shroud of fine material, a cocoon that obscured direct viewing of its nucleus. The object's location added another layer of paradox. It was first detected actively glowing at a distance of over 6 astronomical units from the Sun, far beyond the orbit of Jupiter, in a region of space where sunlight is too weak to trigger significant sublimation in typical cometary ices. Yet there it was, shining with undeniable intensity. Every conventional model of cometary behavior, based on solar radiation pressure and volatile sublimation, failed catastrophically to explain either the magnitude or the steady-state nature of Atlas's emission. For the investigating scientists, the logical next step was to analyze the temporal structure of the thermal signal itself. Specialists began dissecting the infrared time series data, searching for patterns within the seemingly constant glow. What they found was extraordinary. Superimposed on the overall elevated brightness was a secondary, slower modulation, a distinct repeating cycle where the core's luminosity would gently swell and then recede over a precise 4-hour period. This heartbeat was clean, coherent, and showed a waveform that suggested a controlled, oscillatory process, not a stochastic eruption. Dr. Alina Morovich, lead scientist on the JWST analysis team, noted, "The thermal output displays a periodicity that is completely decoupled from the object's rotation and its solar exposure. The energy appears to be generated and regulated internally by a mechanism we do not yet understand. The investigation then expanded into the radio spectrum. A coordinated international effort, utilizing radio telescopes from the Allen Telescope Array in California to the Meerkat Array in South Africa, pointed their dishes toward 3 I/ATLAS. After painstaking data, filtering to remove terrestrial interference and cosmic background noise, a signal was isolated. It was a faint narrowband radio pulse, repeating with clockwork precision every 4 hours, exactly in phase with the slower thermal cycle detected by JWST. Fourier analysis confirmed the signal's artificial seeming structure, a coherent carrier wave. Its timing was not random. It exhibited subtle but consistent variations that correlated with changes in the local density of the solar wind, as if the signal propagation was being slightly affected by the very medium it traveled through. Independent verification from observatories across the globe ruled out equipment malfunction or local radio frequency interference. The signal was extraterrestrial in origin and emanated from the object itself. The scientific community was now grappling with 2 synchronized anomalies, a rhythmic thermal pulse and a coherent radio emission. The most unsettling development was yet to come. In mid-August, JWST's continuous monitoring captured a sudden dramatic event. Over a period of less than 60 minutes, the overall infrared brightness of 3 I/ATLAS increased by approximately 40%. This flare was simultaneously confirmed by Hubble, TESS, and several orbital monitoring satellites. It was a massive, rapid release of energy across multiple wavelengths. Almost concurrently, orbital dynamicists at the European Space Agency's NEO Coordination Center, led by Marco Micheli, ran updated trajectory calculations. They discovered a discrepancy. The object's path was deviating minutely but definitively from the gravitational trajectory calculated months prior. 3 I/ATLAS was exhibiting a non-gravitational acceleration, a change in its course that could not be explained by the sun's gravity or the rocket-like effect of normal outgassing. The timing was provocative. The significant energy release and the initiation of the trajectory shift occurred in close conjunction. For the first time, the data suggested the possibility of a maneuver. Spectroscopic analysis conducted by a team at Johns Hopkins University added another profound layer of mystery. While the spectra showed faint traces of common cometary volatiles like water and carbon dioxide, these were overshadowed by a series of strong, unidentified absorption bands. The reflectance profile indicated the presence of complex metallic alloys on or near the object's surface. Some spectral signatures tentatively matched those of refined rare earth elements and other sophisticated composites, known only from advanced laboratory synthesis and theoretical material science papers. There were even hints of spectral features predicted for exotic, engineered quantum materials that do not occur naturally. By late August, the situation escalated from a scientific puzzle to a potential planetary security concern. Access to the raw, real-time data, feeds from JWST and other major observatories, was suddenly restricted under new protocols enacted by NASA and ESA, officially citing the need for controlled analysis and planetary safety assessment. Behind closed doors, a classified international working group was convened. In a decision fraught with historical significance, this group voted to conduct an active SETI experiment. A directed radio message containing a sequence of prime numbers, fundamental mathematical constants, and the universal periodic table of elements was transmitted toward 3, or R/A/TLAS. The wait was agonizing. 72 hours later, a response was detected. It was a distorted but unmistakable narrowband pulse, received precisely within the calculated transmission window. The event was immediately classified top secret, and all related communication was moved to encrypted channels. The public astronomical community, unaware of the communication attempt but privy to the growing list of anomalies, convened an emergency session. The International Astronomical Union reviewed every conceivable natural hypothesis. Unusual asymmetric outgassing, internal radiogenic heating from rare isotopes, light scattering effects from an exotic dust mantle, and systematic errors in mass estimation. One by one, each hypothesis was formally rejected for failing to account for the entire interconnected suite of anomalies: the excessive brightness, the dual thermal radio pulsations, the spectral signatures, and the non-gravitational acceleration. As the September close approach of 3I/ATLAS to the inner solar system nears, the world's astronomical infrastructure is on high alert. Every major telescope from radio arrays to optical and space-based observatories is scheduled for dedicated tracking. The collective findings are irrefutable. 3I/ATLAS emits like an artificial power source, signals with coherent radio pulses, carries material signatures of advanced fabrication, and has demonstrated a capacity to alter its path. The official conclusions of mainstream cometary science have been rendered obsolete in this case. One fact is now clear to all. 3I/ATLAS represents a profound challenge to our understanding of natural celestial objects. Its upcoming flyby will not merely be another astronomical event. It is poised to become a defining moment for science, potentially marking humanity's first encounter with a non-human technological artifact. The wait for a definitive answer is almost over.